Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access course page on my personal website arif.me. You can click the appropriate link under this lecture resource column to view it in NB Viewer and run it online in Binder. The other way is to download the notebook from the course GitHub repository, Arif PUCIT, and all the notebooks for this course are housed in this public data science repository. Well, this is the Jupyter Notebook dashboard running locally on my machine at port 8888. And here is the notebook for lecture number 13 of the third module, Python Programming for the Data Scientist, for the course titled Tools and Techniques for Data Science. My dear students, today is the fifth session on Pandas, and today we are going to talk about indexing, subsetting, and slicing Pandas data frames. A bit of motivation to understand this session. My dear students, most of the time you have very large data sets loaded inside your data frames, and you may be required to select specific records of your own interest. Maybe at times you need to filter certain rows. For example, in case of a medical dataset, you may be required to filter records of all those patients who suffer with a specific disease or who have a specific blood group. In a travel dataset, you may be required to filter hotels inside maybe the Lahore city of Pakistan, sorted by their minimum per day cost. And similarly, maybe in case of client datasets, you may be required to filter out all those clients who are using Gmail accounts. Anyway, well, this is the learning agenda of today's notebook. Once again, we will start by understanding the anatomy of a data frame. We will understand the column as well as the row indices that are used in a data frame. We will see how we can select rows and columns based on three different techniques. The first is using the simple subscript operator with the data frame name, and the other two are using the iloc and the loc method. And finally, we will see conditional selection based on a specific criteria or maybe based on some specific data type. Okay. Well, my dear students, we have seen in our previous session of Pandas series that a series is an object like a 1D array capable of holding a sequence of values of any data type. Over here, they are floating point. And unlike arrays, every data value has an explicit row index associated with it, which can be a numeric value as shown, or maybe a string as well. We have also seen that we can use these indices for three purposes: for accessing the elements, for subsetting or slicing purposes, and we have also seen an implicit use of these indices, and that is that they can be used for alignment while performing arithmetic operations on two different series objects. Well, today we are going to practically understand the same for the Pandas data frame data structure. My dear students, since a data frame is a 2D labeled data structure, so it has two indices. A row index that moves from top to bottom is associated with rows of a data frame. A column index that moves from left to right is associated with the columns of a data frame. By default, the row indices starts from 0 and ends at n minus 1, where n is the total number of rows in a data frame. Well, this is actually an integer identifier for the rows. Similarly, The column indices by default also starts from 0 and ends at n minus 1, where n is the total number of columns in a data frame. And this is actually an integer identifier for the columns. My dear students, we have also seen in the previous session that when we load a dataset from a CSV file inside our data frame, normally the column labels are set as per the first row of the file, which are normally meaningful names of the columns. And this is what is shown in this image as well. The meaningful column names are name, age, address, the cell phone number, and the blood group. We have also seen that after creating our data frame from scratch, or maybe after reading a data frame from a CSV file without column labels, we can set the column labels by assigning a list of meaningful names to the columns attribute of a data frame. Okay, so now with this quick recap about the anatomy of a data frame, let's start practically understanding the indexing concept in a data frame. Well, let us first understand the data frame. We are going to read group data.csv. This is the same dataset that we have been working on in the previous session as well. I'm using the read underscore CSV method of the pandas to read this inside our data frame. Okay, so this is the dataset having 16 rows and 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 columns. It contains roll number, name, age, address, session, group, gender, and 2 subject marks and scholarship, just a hypothetical data. Okay, so we have seen previously as well, we can get the shape of our data frame. This shape attribute returns a two-value tuple containing the rows, number of rows, and the number of columns. And remember once again, these number of rows does not include this header, and these number of columns do not count this 0, 1, 2, 3, 4, that is the row index. And similarly, we can check the index attribute, which are right now the row indices start from 0 and stop at 15. We can check out the column attributes, which are of course roll number, name, age, and so on. Note there is a space inside this column name, that is roll number. We can check out the data types of all the columns of the data frame. You can see the age is of int 64 type, and this subject 1, subject 2, and scholarship are of float type, and rest are object types. Well, we have also seen this method, info method, that provides information about the data frame, including the indices, the column names, the non-null value count. You can note that this column, subject 1, has 15 non-null values. That means it has one null value as well. And this scholarship has 14. Let's check this out and verify this. This scholarship has 1, 2, NaN values. Great. Okay, so this describe method as well. This describe method is actually when not passed any value over here inside the argument list, it returns you the descriptive statistics about the numeric columns only. So we have 1, 2, 3, 4, 4 numeric columns. So we have got the count, mean, standard deviation, min, max, and so on. Okay, let's see how we can change the column indices or column labels of a data frame. Let me once again load this and show the first 5 records of this data frame. Group data.csv loaded in df. My dear students, this file has these column labels. By default, normally if this file do not have the first row containing these labels, these will be mentioned as 0, 1, 2, 3, 4, and so on. Let's see how we can change this. Rather, we have a file that is without column labels. Let me read that file for you. So once I read this file, uh, since this file do not have the first row as the column labels, and this read CSV assume that the first row will be column labels, so it has mistakenly placed the first data, the first record of this file as the column labels. So if you are reading such files, we have seen in the previous session that we have to pass this argument to the read CSV file, that is header is equal to none. So if we pass this file, now it will read it correctly and it will provide you the implicit column labels that are 0, 1, 2, 3, 4 and so on. Let's suppose we have read this file and now we want to assign some meaningful column names to this data frame, which always makes sense. Well, there are many ways to do that, and the easiest that we have seen in the previous session as well, and that is you assign the columns attribute of a data frame a list of column names. So I have created a list of column names, appropriate column names related with this data set, and I have assigned that list to the columns attribute, and let's check that out. And you see, and this operation is of course in place, so that data frame is changed now, so this looks better now. Okay, fine. Normally we do not keep spaces in between the column names. So if you want to change this roll number, roll space number to a new value, suppose a roll number without a space, we can use the rename method. So let me do that as well. The rename method of the data frame is passed one required argument, and that is a dictionary that contains the old value and the new value. So this is the old value with a space and this is the new value. And if I want this to happen in place, I will use the in place argument as true. By default it has the value of true, but over here I have passed in place is equal to false. So this method will return a new data frame in which this roll number with a space will be changed with this new label. And remember, this data frame is not changed. We have just got a new copy of the data frame. Okay, and there are other ways as well using which you can do that. And one is that you pass a list of column names to the names argument while reading a CSV file. Anyway, so let's move ahead and think of changing the row indices or the row labels of a data frame. Let me show you the data. I have just read the first three rows of this data frame to keep the screen displayable to you. Let's suppose that we have this data frame in which the row indices are 0, 1, 2, 3, 4, so on. And we want to assign some meaningful index to the row labels as well. And suppose I want to set this roll number as an index. And it is assumed that this roll number will be unique, so there will not be an issue. So how we can do that? We can use the set index method of the data frame. This set index method can be used to set any of the column as an index of this data frame. So it is passed many arguments. The first is the required argument, and that is the column name which you want to set as index. So I have passed that argument as roll number. Remember, once again, we are using this data frame having a space in the roll number. And there is another argument that I'm passing, that is drop is equal to false. By drop is equal to false means it will not drop the existing column, that is the index column right now. By default its value is true. Let me show you this. You see now the roll number, this column has become the index. However, the previous column, roll number that still exists over there. If you do not want that to be part of the data frame anymore, you can say drop is equal to true. And I've done that over here so that you have a fair idea. Now the roll number column has come over here. There is no roll number column over here. Once again, another point to note that no change has been made in the original data frame, which called this method set index, because the in place argument is by default false. So that is why it has returned a new data frame. If I pass the in place argument to true, this method will return none and it will make changes to this data frame. Okay, so I've done that as well. So let me run this code. Great. So we have now the DF data frame that is something like this. Remember, this roll number is no more data of this data frame now. Let me check out the df.index attribute. Now this index attribute shows you that the index is now this list, string labels. My dear students, if sometime later you want to reset the indices back to the default, you can use the reset underscore index method. And this reset underscore index method is having no required argument. Just use this method and it returns a new data frame, and that data frame has again made this roll number back inside the data frame data, and this index is now 0, 1, 2 and so on. Okay, so you can use these arguments as well. Drop is equal to false and in place is equal to false if you want to. But anyway, let's see now. We have a fair idea about the indices, the row indices as well as the column indices. Let's see how we can select columns and rows of a data frame using the data frame name followed by the subscript operator. For better understanding, I have created another data frame. This is the same data frame, but this time it is sorted by the age of all the persons whose record is there inside this data frame. Note the age 16, then 18, then 20 and so on. So this data frame is sorted. This is the same data frame. The point to be noted over here is that the indices have been shuffled accordingly. These indices have been associated. This 5 index has been associated with Mohit. You can check it out over here. Suppose over here you see that Rauf is at index 0 over here. And if we see over here, this Rauf is at index 0. So once we sort this data frame, the indices, the row indices stays with the rows. Okay. Well, to access the columns of a data frame, my dear students, you can pass the column name or column index inside this square bracket. In this case, these are strings and they can be integers as well. And whenever you pass a column name, a single column name over here, it will return a series. For example, if I will pass name over here, it will return this column as a series object. And in case if we want to access multiple columns, we can pass comma separated columns labels or indices over here. And in that case, it will return a data frame object. So this was about accessing the columns. If you want to access the rows, my dear students, you just cannot specify a single index over here to get the row. You need to pass a slice object inside this straight brackets. And we all know about the slice object that has 3 components: start, stop and step, separated by colons, and none of them is required. You just need to put a colon at least. And the default value for start is 0. It is inclusive, and the default value for stop is the total length of this, and the step value is 1. And remember, the stop value is not inclusive once mentioned. Okay, so that is it. And one more thing, that if you want to select rows and columns, you want to get a subset, you cannot do that using this straight bracket. For that, we will soon see the log and the iloc methods. And one more confusion, my dear students, which normally come across for the students who work on 2D arrays, they normally use the two subscript operators, and they can easily access the specific element in case of 2D numpy arrays. But over here, you cannot use the this notation or this syntax to access the exact element if you want to access in case of the data frames. Okay, now enough of theory. Let's practically understand this. Once again, let me create a data frame from the same group data, and I am using this time the sort underscore values method and passing it the column name age. We will talk about this in detail in the next session. For the time being, just remember the sort values method when called on a data frame and you pass it a column, it sorts that entire data frame as per that column. And I've just shown you the head of it, and you see this is sorted. We have Mohit at the first location now. And this is the same screenshot that I've mentioned over here for clarity. And this data frame has been named now as df underscore sorted. Okay, let's move ahead. Let's see this example. Let's suppose, gentlemen, we want to select data under this name column. And since the column labels are strings, so I have just mentioned that string over here inside the subscript operator. And of course, as I have said before, this will return a series object. Let me run it. So this is the series object that returns all the names from this data frame, all the values of the names column. Okay. Oh, well, remember, since this is a series, you can always call the methods associated. You can call the head method on this. So it will just return the initial 5 rows. Let's see another example. In case if you want to select multiple columns of a data frame, you just pass a list. You just pass a list inside this straight brackets. Remember, we have double brackets now. This is a list. We have passed this list to the df sorted data frame, and it will return this time a data frame that will be having 3 columns: the name column, the age column, and probably the address column. No, roll number, age, gender, and age column. And I'm just getting the head to save space. So this is it. Once again, my dear students, remember these column names are passed as a list, and that is the reason of these 2 brackets. Let's use a slice object inside this straight brackets. And over here I'm saying start from a row at position 1 and at 2, which is not inclusive, with a step of 1. And of course, this will just return a single row, that is the row at position 1. So this is the row at position 1. My dear students, please note this thing, that this is the row returned which is at position 1, not at index 1. Let me show this to you over here. Okay, it is available over here as well. So this is the first position, rather the position at 0 index. This is a row at position 1 index, position 2, position 3, and position 4. Once we use straight brackets with the data frame name, it does not return, and we use the slice object over here, it does not return the row related to that index. Rather, it returns the rows related to the position of that data frame. So Let me show you another example over here. Let's suppose that I want to select the rows from positional index 2 to 3. This 4 is of course not inclusive. Let me run it. So it is not showing me the records who are having indices 2 and 3. Rather, it is returning me the two rows which are at position 2 and 3. So let's check this out. Position 2 and 3. What are the records at position 2 and 3? 0, 1, 2 and 3. At 2 we have this roll number 4, and at 3 we have roll number 12. So we have roll number 4 and we have roll number 12. I hope this is making sense. And this will of course do what? This will select the rows from positional index starting from 0 till the end with a step of 5. Starting from 0 till the end with a step of 5, that means 0, 5, 10 and 15. Let me run this. So at position 0 we have this record, at position 5 we have this record. Let me verify this to you. At position 5 we have record of Fatima. 0, 1, 2, 3, 4 and 5. At position 5 we have record of Fatima. Remember, once again, once you mention the slice object over here inside this straight bracket with the data frame name, you are actually mentioning the positional row indices, not the actual indices. Okay. Fine. Okay, so this is done. This is done. Okay. Let's suppose that we want to reset the index, a subset of index of a data frame. Let me show you this. Let's suppose that I have sliced a data frame, and I have sliced it that I want all the rows from 5 to 12 with a step of 2. So I've got these 1, 2, 3 and 4 records. Note the indices are randomized. For my ease, I just want that they should be 0, 1, 2 and 3, so that I should be comfortable while working on this data frame, which is a subset of this data frame. And remember, I have received it in df2. So I have called the reset index method on df2, and this will reset the index 0, 1, 2 and 3. Once again, note another thing, that the index has been reset. However, the old index, that is this one, containing these values 14, 10, 4, 15, 14, 10, 4, 15, this has been added as a column in the data frame. And most of the time this is not required. So to the reset underscore index method, you pass drop is equal to true. Once you pass this argument to this method, it will not make this old index as part of the data frame. Let us do that as well. Great. I hope this makes sense to you all. Fine. So this was about the rows and columns selection using the straight bracket or the subscript operator. Let us talk about the iloc method now. Once again, this is the same sorted data frame, sorted with the age, having these indices randomized almost. My dear students, this df .iloc, this is called a method, although used like this. This is more powerful than the df, simple subscript operator, as it allows you to filter the rows as well as the columns at the same time, which is not possible with this straight bracket operator. The point to remember is that like the straight bracket operator, this iloc also use the positional indices, not these indices with these literal values. It is passed two arguments, comma separated two arguments inside this straight bracket. The first argument are basically tells you what rows you want to select from this data frame. And after the comma, this second argument tells what are the columns that we want to select from this data frame. Okay, so you can use colon in between anywhere and use the slice operator for the rows and for the columns as well. Uh, Remember, for rows or the column values, these are the possible allowed inputs. You can mention a single value over here. You can mention a list over here. You can mention a slice object over here. And as usual, remember the stop value once you mention the slice object is not included, as we have seen in all of the Python slicing concept. Okay, so I think enough of theory. One more thing that we can mention a Boolean list over here as well for conditional selection. I will touch upon that by the end of today's session, inshallah. Okay, let's see this practically now. Let me once again load it fresh, the data frame, the same data frame containing 16 rows. Over here, I'm just showing you the first 5, the head of it. And let's suppose that I just want to select a single row of the positional index 2, 0, 1, and 2. Remember, this row will be selected. And remember, this time we have two values over here. I am saying select row number 2, and for row number 2 select all the columns. So this is the slice object saying all the columns. My dear students, remember we have selected the record of Hadid with positional index 2, 0, 1, and 2. So it has not selected the record pertaining to Shaista, which is at index 2, but at positional index 0, 1, 2, 3, 4, 5, 6. So this is the important tricky point that you should always keep in mind. Okay, let's see this. Suppose we want to select these 3 rows. I have passed it as the first argument 3 comma separated values as a list, the row at index 2, positional index 2, positional index 4, and 1. And over here I have said select all the columns. So before running it, let me check out what are the records at position 2, 4, and 1. 0, 1, 2. At 2 we have Hadid, 4 Sara, and 1 Mujahid. So Hadid, Sara, and Mujahid. So this should be the sequence over here. Hadid, Sara, and Mujahid. My dear students, I hope this is making sense. Please do play around to have a crystal clear understanding of how iloc works. And the point to keep in mind is that these are the positional indices, not these indices in their literal meaning. Okay, let's see this example. This says that a slice object over here as well and a slice object over here as well. And this slice object says that select the rows from 3 to 5. 5 is not inclusive, so record 3 and 4 only, and all the columns. And 3 and 4, 0, 1, 2, 3, and 4, Maz and Sara. So let us check this out. Maz and Sara. Great. My dear students, in all of these examples in which I have shown you the use of iloc, if you omit this comma and this colon afterwards, Pandas will assume it and it will give you the same output. Let me show you this thing. Let me comment this and let me run this. This will give you the same output. But this is a bit confusing to me. I strongly recommend that you should use this code instead for clarity. Great. One more difference, just keep in mind that once you are specifying a list, you need to enclose it, of course, in bracket. And once you are mentioning the slice object, you need not to have enclose it inside the brackets. Great. And over here we have just selected the rows using iloc. Let me select the columns now. And before doing that, let me show you the column indices. These are the column indices or labels or strings. And let's suppose that I want to select all the rows. So for the rows part, I have used this column over here, the slice object showing select everything from the rows part. And for the columns, I have just said select the column at positional index 3. Once again, my dear students, this iloc will not work with these string labels. You need to remember that you need to pass a positional index. So this is 0, this is 1, this is 2, and this is 3. So I will get all the columns under the column at positional index 3, which is this address, and this is it. So this is a series object. Of course, once I will get only the column, a specific column, I will get a series object. Okay, let's see this example. I am saying to iloc, please select all the rows, and from the columns part, just select these three columns. And once again, the column at positional index 1, 4, and 5. Let's check this out. 1, 4, and 5. So name, session, and gender. These should turn up over here. Name, session, and group. 5 is group. Okay, 0, 1, 2, 3, 4, and 5. Yes, 5 is group. Excuse me. Remember, this will return a data frame. Okay, now what this is saying to iloc, select all the rows, and over here now instead of passing a list, I am passing a slice object. And the slice object is the start value is 2, the end value is 5, which is not inclusive. So it will return 2, 3, and 4. So these are the three columns which will be returned, 2, 3, and 4. Let's check this out. 0, 1, 2, 3, and 4. Age, address, and session. All the records of age, address, and session will be displayed. Great. Okay, my dear friends, this was using iloc to select only the rows, to select only the columns. Now let's see whether we can subset both. Once again, remember two arguments. What rows do I want and what columns do I want? And let me say this time, I want row 3 and 0. Remember, positional index. And from 3 and 0, I want column at positional index 1 and 5. So this is the third row, this is the 0th row, and this is the column at index 1, positional index 1, and this is the column at positional index 5. I hope this is making sense to you all now. And over here, this is saying select the rows from 0, 1, 2, 3, and 4. This 5 is not inclusive. And over here again, I am using a slice operator, which is saying select columns at position 2 and 3 only. So at position 2, we have age, and at position 3, we have address, and these are the rows. Okay, great. Right, my dear students. Now, after iloc, let me talk about the third technique, that is the loc. My dear students, this is also similar to iloc. Just keep in mind the differences. It is also passed to arguments or two values separated by commas, the rows to select and the columns to select. And you need to remember one point in this, that this loc will work on the actual rows and actual column indices or their labels, whatever. This will not work on the positional indices inside the rows and over here in the columns. Let me repeat this again, my dear students. This loc method works on the literal indices. So if I ask it to select row at index 11, it will select Mars. It will not just count to the positional index 11. So over here you can pass these labels as well to this. One more difference that I will like to keep you in mind is that once you pass a slice object to this loc, this stop value is inclusive, and this is what is different from what we have studied so far. Okay, so let's practically see this as well. So this is once again a refreshed data frame, df underscore sorted, and these are the first 5 rows and all the 10 columns. Let's use loc method to select the rows first. So I am using loc method now. I am saying select the row with index 2 and all the columns related to that. Row at index 2. So row at index 2. It will not be 0, 1, 2. It will not be this row, Hadid. It will of course be Shaista. Let me run this. So you see, Shaista record has been displayed, and since this is a single record, so it has displayed it as a series. Of course, I can select multiple rows, 2, 4 and 1. Remember, this 2, 4 and 1 are not positional indices, rather the literal indices, and I want to select all the columns related to these 3 rows, 2, 4 and 1. Let's check this out. 2 is over here, where it's 2, yes, Shaista, 4 Zara and 1 Arif. So Shaista, Zara and Arif. So we have Shaista, Zara and Arif. Remember, this loc method expect indices, the row indices in their literal meaning, note 241, and the column indices as well in their literal meaning. Soon I will see this as well. And similarly over here I am passing a slice object and I am saying 5 2 3. So note this 5 2 3. In the normal circumstances this will flag an error, but over here it hasn't. 5 2 3. Both are inclusive. What does this mean? Let's try to understand this. 5 2 3. Okay, so this is 5 and this is 3. So it has started from this index and moved ahead till the time it comes up with 3. So if I say 5 to 2, so it will show me all these records. So let me show you this. 5 to 2 over here. You see, 5 to 2. So this doesn't have that concept which we are normally used to of. And using that, let me try this as well. I've requested loc method to give me a slice from index 3 to 5. And instead of returning 3, 4 and 5, 3 records, it has returned me none. Why it is so? Let's check this out, 3 to 5. Okay, so it has started from 3 and moves ahead and it never turns up with 5. So it has never turned up 5, so that's why it has returned nothing. So if I pass at -1, probably in that case it will probably give me these 3 records. Let's check this out as well. A step of -1. Great. My dear students, I am going very slowly. I have tried my level's best to make this example as simple as possible so that you should have a very fair understanding of how we can slice our data frame using the three techniques. Okay, so over here we have sliced the rows. Let's see how we can slice the columns. For that, let me check out the column names. And over here I'm saying to the lock method, select all the rows, and I just want the column having the column name. So it has returned me the series. Great. And over here I'm saying again to the lock method, select all the rows, and from the column part I just need these three columns. I have mentioned the names of the columns. Great. And in this example, I am once again saying to the lock method, select all the rows, and over here, see the beauty, I am saying I need a range from name to address. Okay, so name to address. From name to address. These three columns will be displayed, name, age, and address. Let's check this out. Great. And let me exactly over ensure this by reversing this and saying select from address to name. And of course it has returned me nothing over there, just the indices labels have been displayed because after address the name never turns up. After address the column having name never turns up. So this is the same that we have seen in case of rows as well. Okay, now we can of course select both the rows as well as the columns using the lock method. Over here I am saying it, select row number 3 and 0, row with index 3 and 0, and select only these two columns. So I passed two lists now. And over here I am saying select a range of rows from 3 to 13. Remember, this 3 to 13 are the literal indices, not the positional indices. And from 3 to 13, I am saying that show me these three columns. So you see, this 3 to 13 has not displayed us about 10 rows. It has just displayed us 3 rows, 3, 11, and 13. Let me show you the diagram again to make you understand this. Okay, it is quite up. 3 to 11. 3 to 11. So it was 3 to 11. So that is why it is showing me over here 2. Let me check this out over here. It is 3 to 11. Sorry for this wasting of time. 3 to 13. And of course 3 to 13 we have 3. Let me check this out again. 3 to 13, from 3 to 11 and 13. So these three records are there. So I hope this makes sense to you. I don't want to confuse you much. Okay, so great. So this is the same which I am shown, and over here I am saying 5 to 8. So probably this will also show you almost the entire record from 5 to 8. Instead of showing you 3 records, it's showing you all the 16 records, because the index 5 is at the very beginning and index 8 is at the very end. Okay, so after having understood all of this, some of you might be thinking that this is I don't know why you are teaching these things to us. So this was just for the understanding, because you might turn up sometime in the industry with these issues. So always remember, keep the row indices of your data frames not in the randomized fashion. Keep them 0, 1, 2, 3, 4, 5, 6, and so on. And keep the column indices to some appropriate meaningful names. Whenever you sort some data frame, or you perform some slicing of a data frame and the indices are disturbed, please call the reset index method so that the indices again comes to 0, 1, 2, 3, 4, and you do not have to memorize all this nonsense that I have discussed so far. Okay, anyway, let's move ahead and talk about the conditional selection now. My dear students, now this is the normal data frame. Remember, these are the regular indices 0, 1, 2, 3, 4, so on to 15. The column names, no issue. And suppose we want to select only those records of those people, of those persons who are having ages greater than 40. So I want to select Rauf, Arif, I don't want to select Shaista, Adid, Zara is 40, so, and Zobia is 40, and Adris, and so on. So how to do this? Let me load this data frame, show this to you. So this is the data frame on which I'm going to work now. Option 1 is, my dear students, you create an empty list, you enter inside a for loop, and inside the for loop of this data frame, you check out this age, so df.age. So every time this loop will iterate, this length value will have this age, 52, 51, 35, and so on. And over here I'm checking out if this length value is greater than 40. You just append true to this list, and otherwise you append false to this list. This is simple. Let me run it. So you see we have a list, a Boolean list of having 16 values, having true at that place where the age is greater than 40, and false at the place where the age is not greater than 40. Let's check this out. The first two values are true, and then the remaining few are false. This is true, and then we have false, 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 and again this is true. So we have got a list, a Boolean list, and we just pass this Boolean list to the data frame and see the magic. It has returned us only those rows or records of the students whose age is greater than 40. Hope this makes sense. But there is a simpler way to do that, and that is you just pass this condition to inside the subscript operator. Instead of using this loop and creating this list and then passing that list over here, you just pass this condition which says df.age is greater than 40. So this will run for all the rows of this data frame and will place a list over here, and it will give you the same result as above. All the students having age greater than 40. Great. And the best way to do that is using the loc method, which says that select all those which have the age greater than 40, and it will show you the same result. The power of loc will be apparent to you once you will pass it the second argument. You see, you can pass loc the second argument after the comma, in which you can always mention the column names which you want to select. So I hope this is making sense to you all. And once again, remember, once you slice a data frame using some condition, the resulting data frame might not have the same indices 0, 1, 2, 3, 4, so on. And they may create problems later on when you will slice again from this data frame. So whenever you have done that, please remember you reset the indices if you exactly do not want these indices to remain associated with these records. Okay. So over here we have used a single condition. My dear students, we can always use multiple conditions separated by logical operators. That can be and or. You can always use not as well, which is a unary logical operator. So over here what I'm saying is select all those records who have ages greater than 40, and at the same time of those persons who are living inside the city Multan. So you see there are only two persons who are of age greater than 40 and are living in Multan. Where is Multan? address over here. Yes, Multan. Great. And let's check this out. This is saying select all those who belong to group A and who are male at the same time. These both conditions need to be true, only then this row will be retrieved. So all the students of group A and who are male. Remember, if I use an OR operator over here like this, so it will have all the students of group A and all those who are males. You can see a student of group A who is female over here. So any of these conditions, if they evaluate to true, the overall condition will be true. So let me change it back. Okay. So this is another condition that says that all those students who live in Sialkot or their address is Karachi. So it means, in simple words, display me those records of those students who belong to either Sialkot or Karachi. So Sialkot and Karachi. 3 students of Karachi and 2 students of Sialkot. Great. And over here there is a lengthier condition which says address is not equal to Karachi and scholarship is greater than 700. If both these conditions evaluate to true, then the record will be displayed. And if only this condition evaluates to true, even then the record will be displayed. Okay. And finally, you can use the is-in method as well. You can pass multiple values of list. So over here I'm saying that show me all the students who belong to Karachi, Peshawar or Islamabad. So remember, this is an OR operator, simpler and elegant way of doing that. And last thing, if you want to select data based on data type, you can use the select underscore d type method of the data frame object. And let me show you the d types of all the columns. So we have objects, integers and floats. And let me say that from this data frame, I just want to select only those columns which have the data type float 64. So I will get subject 1, subject 2 and scholarship. So subject 1, subject 2 and scholarship, and of course all the rows. And over here I'm saying just show me the int 64 as well along with float 64, and I have changed this head method ahead, so it has shown me that. Great. So these are just the 5 records because I've used head. Okay, so that is it, I think. Okay, so great. My dear students, this was a lengthier session a bit, but it was important. Please do practice all the concepts related to indexing, subsetting and slicing of data frames using the 3 techniques. Please do practice as how we can change the row indices as well as the column indices. Keep in mind the point of the positional index and the literal meaning of the row as well as the column indices. So that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.